Hey everyone, and welcome. So recently I was participating in a smart contract auditing contest, and I noticed there was an issue, regarding front running for one of the contracts I was looking at, and then I believe there was a solution that could be applied to actually mitigate that risk of front running, but I needed to prove it. So whenever you're doing a bug bounty program or auditing contest, you always need to submit what's called a proof of concept. Basically, it's a executable piece of code. It could be a test, could be a script that's intended to be run locally in a development environment that just kind of shows the exploit and how it could be, that it actually exists and how it's done. So I've never done one though that involved front running, and sometimes I use Hardhat, sometimes I use Foundry. In this case, I was using Hardhat, and I was, since it uses JavaScript, I was trying to play around with things like, async and await, trying to kind of force certain transactions to happen first based on whether I was awaiting the promise or not. That didn't work. I tried making a kind of a symbolic mempool array and reordering the array elements to kind of show how a validator could reorder the transactions. That didn't work. Then finally, I came across this piece of documentation which had the solution in it. So hopefully, I'll save someone else some time with this video here. Um, but here's what it is. So basically, Hardhat can be configured to have two auto mine blocks immediately upon receiving each transaction. This is the default behavior. It's twofold. Basically, there's this mining property within the config that has a default of auto being true, but also with every transaction you send, gas is basically also defaulting to the block gas limit. So even if you were to actually go ahead and turn this off, you would still have to go and modify this gas property here to make it something less than the block gas limit. Otherwise, every transaction is still going to be sending the max amount you can have per block, forcing the network to basically only mine one transaction per block anyway. So if you want to make a permanent solution and have more realistic validation conditions in your tests, you can modify the config file to turn auto mining off, and also make sure you're putting some sort of reasonable gas number there. And then for transactions you want to succeed first, then you can go ahead and programmatically in the tests set those gas limits to be higher than the one that is defaulting to here. So basically, in case you did want to have several transactions per block, but not have that kind of realistic behavior where the transactions with the higher gas are being favored, they still give you the option to put this order here of first in, first out. But this is what we want though. Whenever you're trying to simulate front running, obviously you want the transactions with the higher gas price to be included first, as it would be in the real world. So obviously also I can't disclose any sort of ongoing audit findings while the audit is still taking place. But I did come up with this kind of standard example here of what a front running scenario could look like. This is the classic, so to speak, ERC20 race condition front running issue. Depending who you talk to, they may or may not consider this to be an actual issue or not. And just a full disclaimer here, if you submit this in an audit contest, most likely it's not going to earn you any sort of points or reward for this, because this is a well-known thing and a lot of judges probably don't consider this to be a real issue. But in any case, here's what it is though. This is an actual front running scenario though. So basically you have two addresses. You have Alice and Bob. Bob here is the bad actor. So here's the flow of things. So Alice first approves Bob to spend 100 tokens on her behalf. But she made a mistake. She only meant to do 100 instead of 1,000. So she quickly submits another transaction trying to correct that value here. But Bob, let's say, has access to the mempool somehow. Either he's running a validation node on his own, maybe he's using an API, whatever it is. He sees this transaction in the mempool, so he sets another transaction of his own to spend those 1,000 tokens quickly as possible, and also increases the amount of gas he's willing to pay for his own transaction. So just like validators are supposed to do, they reorder the transactions to prioritize the ones that are more profitable for themselves. Then the 1,000 tokens go to Bob. Then the miners go ahead and take the correction transaction here from Alice and then confirm that one. So now Bob already took the 1,000 tokens from this approval. Then, based on the ordering of things, it now appears like Alice actually approved Bob for an additional 100 when she meant to only do 100 in the first place. So Bob can now go ahead and take those 100 additional tokens, and then instead of ending up with 100 tokens like she intended him to have, he actually ended up with 1,100 tokens. So we can go ahead and simulate this scenario actually now with our Hardhat tests. So If anyone's been watching the Open Zeppelin by Example series and you saw the last video, then that's where we made this mock token using the Open Zeppelin library to make our own ERC20 token. So that's the one we're going to use in this video as an example for the ERC20 token we need to run our tests. But here are the actual tests themselves, though. So when we're setting everything up, we're going to mint 5,000 tokens for Alice. And then with each test, she's going to go ahead and approve Bob to spend 1,000 of her tokens. So we're expecting that, that he's already going to have an approval of 1,000. Then what I forgot to mention a moment ago before I got into the scenario here was that you don't need to actually turn off the auto mining in the config either. If you're like myself, you do prefer that speed that the tests give you by having the auto mine feature or setting already turned on. So it's only in certain select situations where you want to see what happens, when there's realistic conditions in the sense that multiple transactions are happening per block. So if you're like myself, you only want to run that turn auto mine off occasionally, then what you do is you can send a command to the local network to turn auto mining off just temporarily, like in this line right here. So that's what's happening here. So we're turning the auto mining off temporarily, just like in the diagram here. Bob is going to send a transaction to quickly grab those 1,000 tokens, and Alice is going to try and correct her mistake by reducing the approval to 100 tokens. Because Bob has a higher gas price here and a higher gas limit, what's going to happen is his transaction will get mined first. And then let's go ahead and run these tests. We can actually see the transactions in the block here. So if I go ahead and run this test command, it's going to print out a whole bunch of stuff, but we're pretty much just interested in the transactions array here. So you can see there's 2 transactions. Then we send a command for the network to go ahead and mine the block. Then after the block is mined, the transactions are no longer there because they were already confirmed. But at this point, it's too late. Even though Bob's transaction is coming second in the code here, his was actually mined first, and then hers was mined afterwards. So now we can see that the balances are as we expect them to be. So Bob now has 1,000 tokens in his account instead of just 100, and then Alice now is down to 4,000 instead of 4,900. And Alice's approval reduction is now useless pretty much, and still can be taken by Bob, which is exactly what happens next. And then Bob went ahead and took the remaining tokens, and then actually might as well go ahead and validate those balances too, just to be thorough here. So let's go ahead and copy this down and write check balances again. And at this point, Bob has the extra 100, and poor Alice is now down to 3,900. The other scenario is, let's say she meant to approve him for a higher amount than 1,000. She actually meant to approve him for 2,000. Well, same thing applies. Bob can quickly grab the 1,000. The 2,000 approval gets confirmed afterwards. Now Bob can go ahead and help himself to the 2,000. And instead of getting 2,000, he now has a total of 3,000, which is 1,000 more than what she wanted him to have. And then let me go ahead and actually just run those tests one more time to make sure that the little ending part here we added also asserts to what we expected it to. And there it is. So they both passed. So like I said, I spent probably a good couple of hours just trying to figure out how to realistically show a front-running scenario in a proof of concept that could be used in a bug bounty auditing contest. And now that I found a solution, for anyone else out there who's trying to write a similar proof of concept, hopefully this will save you a little bit of time. In any case, if you like this video, please go ahead and subscribe, and hope to see you guys in the next one.